Welcome to the Digital VLSI Design class at the University of Utah. My name is Pierre-Emmanuel Guerardon. I will be your instructor for this semester. In this class, you are going to learn how to make silicon chips. In this picture, you have the example of an Intel i7 processor. You will recognize many different aspects of the processor, going from highly regular memory structures to versatile data path logic. In this class, we will learn everything about that, as well as use the tools to build these kind of structures. This tool, obviously, being a 5000, 6000 level class, has significant prerequisites. The official prerequisite for the class is ECECS 3700, Digital Design. However, you're also expected to have knowledge on the following subjects. Digital logic, you need to understand how to build multiplexers, tri-state logic, finite state machines, and so on and so forth. You need to have some prior experience on hardware description languages, such as VHDL or Verilog. This class is going to use Verilog, and we're going to go over again the various aspects of Verilog. However, this is not a Verilog class. You need to have some prior knowledge on the subject. Computer architecture need also to be generally known. You need to know what the microprocessor organization is, what an ISA is, what various registers would be, and what the general computer organization would be. And obviously, some basic electronics knowledge is also expected. Know how to know resistors, capacitors, inductors, transistors, op-amps, and all the various lower level classes type of knowledge. How to get caught up if it's not your specific field of expertise, or if you are feeling a little bit lost in the material. Well, you can access all the references I will post during the semester on Canvas. You can also browse the web. And finally, and most importantly, you need to bug me or the TAs. Indeed, we cannot guess what missing knowledge you might have. So it is your responsibility to let us know your difficulties, and as a result, will be our duty to help you overcome them. If you need to reach out to me, well, all details are provided on the Canvas page. However, you can reach at any time at my email address that is on this slide. You can also stop by my office, SMBB 3745, but best will be to catch me after class or by appointment. To reach out to your teaching assistants, please contact them using the information that is available on Canvas. Please definitely send questions to me and the lead TA. This class is going to use a textbook, which is Principle of CMOS VLSI Design from Neil West and David Harris. This book is a reference in the field and will contain all the information you need to know about digital logic as well as VLSI design. In addition to this theoretical knowledge type of book, I will also recommend the optional book entitled Digital VLSI Chip Design by Eric Brunvent from the School of Computing. This is a great resource. However, it is currently less aligned with our labs. It is, however, definitely having a ton of information that you'll find useful for this class. So what are we going to do in this class? Well, my goal is for us to cover a broad range of topics of importance for digital VLSI. The goal being giving you the complete foundation of the field. We're going to go back to basic transistor theory, which is our building element of choice for VLSI. And then we'll study how these transistors are implemented in a complete system through CMOS processes and the design. So how those transistors are assembled together to create combinational and sequential elements. We'll also look at the various EDA tools, EDA standing for Electronic Design Automation, and how these tools have been used to revolutionize the field of building very complex chip with reduced manpower. We'll go through the notion of mask layout, how to actually draw a digital circuit on silicon, and the associated design rules. We'll also look at circuit simulation and characterization of those gates. And finally, we'll start digging up in a couple of more advanced topics, such as custom data path design, as well as design validation. Everything will culminate with a complete chip tape-out. The goal in this class is to design an actual system of your dream up to the point of making a tape-out. Tape-out meaning sending the design files to a foundry such that the foundry can build your actual chip. In order to understand the tape-out process, we will build a couple of full custom standard cells. These standard cells are the building blocks of more complex chips that will give us some sort of understanding on how VLSI circuits are built. And then we'll use a semi-custom flow where those standard cells are used to create larger systems in an automated way. And finally, we'll go through full chip manufacturing through a complete project. So what are we going to do to go through all those objectives? Well, we'll have lectures. Those lectures will cover a mix of theoretical and practical topics that will be used to prepare for the labs. And then we'll have a series of 5 labs that will go through the full design flow in a guided way. So we'll start by having a high-level description using HDL, and then we'll go through the various steps up to the fabrication files. We'll also have a couple of graded assignments, essentially homeworks that will help you grasp some better aspect of VLSI design as well as practice a little bit your HDL skills. And we'll have the fairly large design project. In the design project, we'll build the ASIC of your dream. So you'll have to come up with an idea and something that is interesting enough to implement. Get in groups and go through the complete process of getting the specs, designing the RTL of your chip, and finally do the complete implementation. We will also have a unique exam. This exam will basically cover the entire material that we will have covered until this point, including lectures, labs, and homeworks. Finally, graduate students will have an extra assignment necessary for the 6000 level class, and this assignment will consist of reviewing a couple of published chips through solid-state circuits IEEE type publications, ISSCC, VLSI Circuit Symposium, as well as JSSCC, and they will review a circuit or a collection of circuits on a given topic and write a one-page background type report. The grading policy will be published on Canvas, and you can see exactly what will be the differences between the 5000 and 6000 level class. The lab assignment and lab schedule will be given on the syllabus. Labs are to be performed individually. Only the project will be made in groups. The goal for that is for all of you to practice and understand the standard VLSI design flow. We're using a non-conventional model for the lab organization. Indeed, we won't have any specific lab sessions. You will work at your own rhythm from the CADE lab or from your own machine with remote connection to the CADE lab. Note that you will not be able to install the tools on your personal machine because all those EDA tools are subject to very strict licenses only available within your institution or your company in the future. TAs will be available every single day, Monday to Friday, 4 to 5 p.m., unless we provide other directions on Canvas that will depend on the availabilities of everybody. The TAs will be available in the CADE lab or available through Google Meet to meet with your group or to meet with you individually and meet with your group for the project later and answer all your questions. That way, we believe that will give you the maximum TA availability and will allow you to really go through the material very smoothly. Of course, this model implies that you have to start working early on your labs. If you start working early on your labs, you will be able to go ask your question to the TA, continue the work, and do so and so on and so forth during the week. We will not tolerate questions over emails during the weekend if you have not been showing up at least one of the help sessions. If you, of course, have some scheduling issues, let us know. We can find a better time. Last but not least, I said attending one of the TA sessions. Remember what I said. You could get access to your TAs over Google Meet. Use this resource. For the lab reports as well as homework, we're applying a very strict late submission policy. All the labs will have to be submitted by the due date on Canvas. If you have some checkoffs, those checkoffs will have to be done with your TA, either in person or remotely through video conferencing. The lab reports will be due on Canvas on the date indicated on the lab guidelines at 11:59 p.m. of that day. We're going to apply a very strict submission rule. We'll look at the timestamp on Canvas and apply the following rule. First of all, late reports are at risk of not being graded at the discretion of the team, meaning that it could result in a 0. If we still decide to grade your homeworks, we will apply a max grade of 75% for up to a full week of delay, and then 50% beyond that. The goal of this policy is to make sure that you can keep up. So please let us know if you have any kind of troubles. We are always happy to come up with some specific arrangement if you have some issue, medical, with your family, and so on and so forth. Please anticipate. The similar policy applies for homeworks. If you have any questions for your grade, when the grade is released, you have up to 1 week to make a request through the grader or your lab TA or myself. The grader with a higher priority. If after this week you have not made your request, the grade will be considered to be final. Cheating policy is not going to be tolerated in this course. The university, the department, and myself have very strict rules about cheating. You can access the complete policy on Canvas. I know you will hate me, but we're starting already with the homework. What did you expect? You don't have any lab for the first couple of weeks? Were you seriously thinking it was going to be a free ride? No. This first homework is designed to force you to review the basic skills related to digital design that you will need first down the road for this class. It covers standard material from 3700 and will also help me grasp the general level of the class. All details are given on Canvas for you to get access to the homework and for your submission.